Good day. Experiment 5 and 6 are dealing with equilibrium. So you need to revise the Shuttle Use Principle by reading about it in McMurray and Fay. So in experiment 5, we will be looking at the dichromate ion and the chromate ion. So over here on the x-axis you have the pH. So at low pH we are expecting the dichromate. At high pH we are expecting the chromate. Now if you look at this table 5.1, you can see the chromate has got a yellow color and the dichromate has got a orange color. In this case the oxidation states are not changing. It remains +6 in both cases. Now we can also represent this change in speciation by an equilibrium equation as shown over here. So now if you can look, we have the chromate reacting with some protons forming the dichromate ion. So now you can imagine if you have a high amount of protons, it will push the reaction towards the right. So the more you are making it acidic, the more you're disturbing the equilibrium, then according to the Shuttle Use Principle, this reaction will react to diminish that disturbance. So if you have a lot of protons, it will react with a chromate ion and it will form the dichromate. So at a high amount of protons, at a low pH, we will form more of the dichromate ions. So now if you add something like ammonium hydroxide or sodium hydroxide, which is a base, that base will react with your protons to form water. So as you add base, you are decreasing the proton concentration. Now, if you are decreasing this proton concentration, you are disturbing the equilibrium. So now this equilibrium reaction will change to resist that addition of the base, and it will resist the decrease in your protons by favoring the reverse reaction. So which means your dichromate will react to form more protons and the chromate ion. In experiment 6 we will be making metal complexes and be looking at the equilibrium between these two metal complexes. So when we have tetrachlorocobaltate ions, they are blue. When we have hexa-aqua cobalt 2, it is pink. So if we have pink, we have this complex. If we have blue, we have that complex. So now if you look at this equation, you don't see any protons or any hydroxyl ions over here, which means this equilibrium reaction is not dependent on pH. So now if we are looking at this equation, if we start off with cobalt chloride in a dry environment and we are adding water, it will react with the cobalt chloride to form the other species. So we are replacing the chloride ligands with some water ligands. So as we add water, our blue color will disappear and we will form a pink color. Now if we are adding more chloride ions by adding, say, hydrochloric acid or sodium chloride or potassium chloride, we are increasing the amount of chlorides, and you know from the Shuttle Use Principle that the equilibrium will react to counteract this disturbance, and if we are increasing the amount of chlorides, the equilibrium will try to decrease it again by reacting with this cobalt complex to form more of this other cobalt complex. So if we are adding more chlorides, it will favor the reverse reaction. So which means your hexa-aqua cobalt 2 will change and it will form tetrachlorocobaltate 2.